So you are supposed to know from year 9 that a linear sequence is any sequence that goes up by exactly the same amount every single time. So this is plus 3, plus 3, plus 3. Now, even year 8s and year 7s have no difficulty with that concept. And if you ask them to complete, to fill in the next 3 terms, then everybody can do that. Now, if you were in year 9, there'd be 1 mark for doing that, and there'd be 1 mark for doing the general solution. So at the end of year 9, you were supposed to be able to find the general solution for any linear sequence. So I'm going to start off by reminding you what that looks like, okay? It's linear because what you end up with is a straight line. If you go and plot the term number against the term itself, so please remember this is the term, and this is the term number. So you have the first term, the second term, the third term, the fourth term, and we filled in the 5th, the 6th, and the 7th term. So those are very simple concepts. And before you work out the general solution, I would strongly advise you to put the term number in. It really helps to see it there, right? This will give you a straight line graph. So if you were to plot x as being n and y as being the term, then you would definitely get a straight line graph, and that is why it's called a linear sequence, right? So if you go and you plot that, you're going to get a straight line graph. So with any straight line graph, you have the format y is equal to mx plus c. So logically, you're going to have this format there as well, right? But we're not going to talk in terms of x and y, although quite often people do. Quite often it's not in terms of n, but the most formal way is in terms of n. We're going to do it properly. But obviously you should be able to switch variables. Should make no difference if it's x and y or p and q or anything else. Stand this side. You are supposed to know that the formula for the general formula for this thing is going to be n times by, let's make it dn. dn plus the 0 term. This is not something you have to learn off by heart. It's completely logical, right? This is d. So this is the common difference. And it is the only thing that really matters for this sequence. As soon as you've got the common difference, and as soon as you shove it in front of n, you will be able to work out the sequence. You can ignore the 0 term. I'll show it to you now, but you don't need to use it. If I say 3 times n, then I've got 3 times 1, which is 3. I need to get from 3 to 1. So what do I subtract?
1.
No, generally 2. If you look at the second one, if I go 3 times 2, I get 6. If you subtract 2, you get 4. Do you see that? If you look at the third value, n is equal to 3. 3 times 3 is 9, right? Subtract 2, 7. 4 times 3 is 12. Subtract 2. The formula is that, right? So you're looking at this number here, and you're saying, how do I get from here to there? If I multiply it by 3, I'm going to end up with 15. If I subtract 2, I'm going to end up with 13. That's what you're doing. So hopefully it comes back to you because you've done this before. If you look at the 0 term, it's the same thing as saying the 0 term. If I go and I fill in the 0 term over here, if I go back another 3, I will have minus 2. The 0 term doesn't really exist. It's an abstract concept, but we use it for both this one and quadratic sequences to help us find the solution. And if you think about it, if the 0 term is minus 2, you're saying how many groups of 3 would I have to add to get the first term? I'd add 1. How many groups of 3 would I add to get the second term? I'd add 2. How many groups of 3 to get the third term? I'd add 3. That's why it's the 0 term plus however many differences times the term number, right? Do you all remember this? So this, I'm hoping, is relatively easy for you. Thank you very much. Well, how did you know? Wow. Okay, anyway. Thank you. Okay, so here's your second one, right? The first thing you do before you do anything else, remember, you are going to have 3 major types, and you're going to have other types as well that we don't have a general solution for. So if you use the wrong method for the wrong type, you're going to get it wrong. So the first thing you do is look for a common difference. Common difference here is minus 4. Do you think the minus sign matters? Yes, it has mattered for everything in maths for all of your lives. It still matters, except it's minus 6. Yes, thank you.
I
I fully believed you to my math in my brain.
Yeah.
Is that right? And I was like,
Yeah, there's no excuse for that. Thank you. Okay. So, guys, shush. This is all going on the recording. The difference there is -6, okay? So the only thing that really, and again, this is our term number. So when n is equal to 1, then this is term 1. When n is equal to 2, this is term 2. When n is equal to 3, this is the term 3 is -1. Term 4 is -7. Term 5, obviously we're going to -6 again. And term 6, we're going to -6 again. And term 7, we're going to -6 again. So you should be able to, that should be super easy. The only thing that really matters is that -6. So immediately for your general solution or the nth term, and you must understand what they're asking. So they can ask you for the general solution, they can ask you for Tn, they can ask you for the solution for the nth term. Now that is the nth term, do you agree? They all mean the same thing. So they're asking you for Tn, okay, general solution, or equation for the sequence, or solution for the nth term, okay? Then that is going to be -6 times n. Of course, the minus matters, it always has. And now you could use the 0 term or you could not. It doesn't matter. I can just go -6 times 1. That gives me -6. How do I get from -6 to 11? Plus 17. Yes, you need to watch me since I apparently can't add. That is going to be your 0 term. If you go backwards and you look for the 0 term, so if I go and I add 6 onto this one, there's 17, there's the 0 term. If you want to, you can say the general solution is the common difference times n plus the 0 term. Or you can just think it out, common difference, right? Now this is the same formula as this one here. You need to know both because sometimes they're going to give it to you in this format, okay? They are exactly the same thing. They're going to give you exactly the same formula, right? But sometimes they're going to give you parts that you need this to solve it with. So this one over here, this is your first term. N is still the term number, and D is still the common difference. It means it's the first term. What is the first term of the sequence? No, what is the first term of the sequence? Thank you. So there's 11 plus, and then n minus 1, and the difference is -6. Do you agree? And I'm multiplying it, yes? I'm filling in a simple little formula. A plus n minus 1 times by d, right? If I work that out, that is no. I'm going to work it out, and then you can talk to me about it. That is -6 times n, which is -6n. And that is -6 times -1, which is +6. Okay? And we are going to end up with -6n plus 17, which is hardly surprising since it is the same sequence. You will expect the same formula. I'm going to pause. There's no issue here. Immediately you can do the same thing. The common difference is 1/2. So you can say 1/2 times by n. And then you can go back and work out the 0 term if you feel like it. I've been adding 1/2 every time, so it's 0. That is your sequence. Do you agree? And if you look at it, you take the n value and you half it. Half of 1 is generally 1/2. Half of 2 is 1. Half of 3 is 1.5. It was slightly sad, in fact, that I used a formula to find that. The point I'm trying to make to you is that fractions are not a problem, right? Makes no difference. The method is exactly the same. The top one, if you go and you look at the difference between 6/10, which is 1/2, and the difference between 1/6, which is 12/2, and the difference between what is actually -1/7, the difference is not the same, right? So you might decide to yourself that this isn't a linear sequence, but it is. It's two separate linear sequences. I will show you. So if you look at this one, that is a linear sequence. You're going -4, -4, -4. You're going to do them separately. And this one, you're going +2, +2, +2. So when you get fractions, people, we have 3 possibilities. Please listen. The first possibility is that it's a straightforward linear sequence like that one at the bottom, in which case you just do it as usual. Second possibility is that we have two separate linear sequences on top of each other, right? You just do them separately. Third possibility is it's not a linear sequence at all, okay? In which case we'll have to do something different, but I'm not worrying about that for now. This one over here, the sequence is going to be minus 4n. Minus 4 times 1 is going to give me minus 4. I need to somehow get up to 6. So I'm going to be adding 10, right? The sequence of this one is going to be 2 times n, right? 2 times 1 is 2. I need to get it to 10. So that's going to be plus 8. So amazingly enough, the sequence for this combined one is this. The numerator is minus 4n plus 10, and the denominator is 2n plus 8. You just do them separately, right? That's all you do, right? So your term number is going to have to be, a multiple. So I'm dividing both sides by negative 11. So the term number is 8. So for the second question, they've said which term is minus 52. If you go taking away 11s, you'll find it by the 8th term, right? Use your sequence to go backwards. Easy?
Easy.
I hope so. Third one, not so easy. It says the first three terms of an arithmetic, you must find the first three terms. If the first term is 10 and the sixth term is 85. So this is the first hard one you've had. So it says to you the first term, which we know is A, is 10. Remember, A is the first term, right? And then it says to you the sixth term is 85. So that is given, okay? And they've asked you to find the first three terms of the sequence. This is what you are going to do. You are going to remember that the sixth term is 5 differences. Okay, let me just... plus A. So this is using the other formula. So look at the other formula. The other formula says Tn is equal to A plus n minus 1 times by D. Do you agree? That's the formula that I've told you have to know. We know that we're looking for the sixth term, right? So where the n is, we can stick a 6. So I've got 6 minus 1 times D. So T6 is A plus 5D, right? Do you agree? Yes.
So, what are we trying to work out?
The first three terms of the sequence, which we do not have.
But we have. Why are we put 6 in? Because it's the sixth term.
Because otherwise you need some information. So just giving you information. For any linear sequence, right? So now, if you think of it, we know what the first term is. We know that A is equal to 10. Do you agree? It said the first term was 10. And it says, and you know that the sixth term is equal to 85 because they told us it was. So 85 is equal to A plus 5D. What do you have? Yes, what do you have when you have two equations with the same variable? Simultaneous equation. You know what A is? A is 10. You can put 10 inside here, and you can solve for D. So 75 is 5 times D. D is 15. Now you have your sequence. Right? Just let me finish off and then I'll answer questions. So the formula is Tn is equal to A, which we have. So I'm using this thing here. Plus n minus 1 times by D. D is 15. We just calculated that, right? So this is T plus 15n minus 15. So the formula for this sequence is 15n minus 5. Now pause, I'll stop this one. So if we know that the first term is 10 and the difference is 15, surely the second term is 25 and surely the next term is 40. We don't even need this. You will need it for some of the other questions, but you didn't need it for this one. They asked you for the first three terms. You know the first one is 10. Add 15, you've got the second one. Add 15, you've got the third one. Here is example 4. I'm going to just talk you through it. So it says to you the 10th term of an arithmetic sequence. It says determine the 10th term if the third term is minus 4. So first of all, you can write down third term as minus 4, and that means it's the first term plus 2 differences. It's logical, right? And then it says the seventh term is minus 20, so that is the first term plus 6 differences. And then you make a simultaneous equation. So this is just the simultaneous equation here. It doesn't matter which variable you're solving for, whether it's a or d, and I've subtracted because I want a minus a, and it tells me 4d is equal, negative 4d is equal to 16, so d is equal to negative 4. Once I've got d, I can substitute d into any one of these things. I've substituted it into there. I know that negative 4 is equal to a times plus 2 times d, which is negative 4, and a turns out to be 4. So then I know that my first term is 4, because a is 4, and then I know that d is minus 4, so my second term is 0, third term is minus 4, fourth term is minus 8, and it asks you to determine the 10th term. So to determine the 10th term, you can go t, 10, and you could just keep on taking away minus 4s, or you could make this the actual formula, which is better. So the formula says to you minus 4 times n, because the difference here was minus 4, and and the 0 term. Let's just put this in over here. This is term 1, and so the 0 term is going to be 8, so it'll be minus 4n plus 8. So if I want to work out the 10th term, I can go minus 4 times by 10 plus 8. So that's minus 40 plus 8, which is minus 32. And if you count down in this sequence here, going down and down and down and down, you should get the minus 32 as well. The last question over here, you are using the fact that the defining feature for a arithmetic sequence is that you have a common difference. And if you have a common difference, then the second term minus the first term is going to give you the same as the third term minus the second term. So here's a pretend one. If you know, well, it's not a pretend one, but pretend the sequence was 2, 5, and 8, then 8 minus 5 is 3, and 5 minus 2 is 3. So that's what's in the block here. That's what makes an arithmetic sequence an arithmetic sequence. So then if term 1 is equal to 3p minus 4, and term 2 is 4p minus 3, I can say term 2 minus term 1, and I can say term 3 minus term 2, and they've got to be equal to each other. So now you've got an equation with a single variable, so you can find out what p is. So you're going to drop the bracket, notice that becomes positive, drop the bracket, notice that becomes positive, add everything up, and p is equal to 2. Once we know what p is equal to, we can go back here at the top, and we can substitute in 3 times 2, so 3 times 2, because p is 2, minus 4, the first term is 2. 4 times 2 is 8, minus 3, the second term is 5. The third term is 7 times 2, minus 6, and that's 8. So we weren't working out n or tn, we were working out p and working it out to find out what the terms are. So the actual terms are 2, 5, 3, and you can then work out the sequence for this particular thing. It's going to be 3n and then minus 1, and then it says which term is the 62. So the actual term is 62. They're asking you for the term number. You substitute it in, and you solve.